Problem number 46 in 6.4 tells us that we have a drawer. Let's draw our drawer. And in this drawer, we have 10 white socks and 6 red socks. So we've got a total of 16 socks. And we want to know what is the probability that we pick a pair of socks. So we're going to get R is equal to 2. We're going to pick 2 socks. What's the probability that both socks both are the same color? I'm going to write that in English. Give me a chance to think about it. Both are the same color. So now here's the question. How can we get both of them to be the same color when we're using W's and R's, whites and reds? We can do this if we write this as, we want both the same color, so we could get both white or both red. So what I want to do now is I want to write this in terms of what I have in here. How can I get both whites in terms of whites and reds, and both reds in terms of whites and reds? So this is going to be the probability of, here's what we want. I think what we want here is both whites. So I want 2 whites and 0 reds, or I want 0 whites and 2 reds. Close and close. Now what this does is give me how I can get the whites in terms of white and red, what I have in here, and the reds in terms of what I have in here. Now I can get the count. So what we have here then is out of 10 whites, we want any 2 of them, and out of the 6 reds, we want none of those, or is the plus. Now over here, 0 whites, so out of the 10 whites, we want none of those, and then what we want is 2 reds, and we have 6 reds from which to choose, so out of those 6, we want 2. Now it's a probability, so we're going to have a denominator here, and our denominator is the total number of ways that we can choose 2 socks out of our 16, right? We've got 16 socks, we want any 2 of them, so this is 16, choose 2. And this is what we're looking for then. That's the probability that we want. And when I computed this, I got 0.5. In problem 48, we're told that the winning combination in the Swiss lottery consists of 6 numbers drawn from the numbers 1 through 45. So I might think of this as we've got a box with these numbers 1 through 45, right? So N is equal to 45 and R is equal to 6. And what we want to know here is this. What is the probability that when we draw 6, we get no matches? We get no matches. Like our ticket with 6 numbers on it does not match any of the numbers that were drawn. So let's count. Maybe out of those 6 numbers that were drawn, we want none of those. Now there's 45 altogether. We've chosen 6, so that leaves 45 minus 6 is 39. And out of those 39 that don't match what was chosen, we want all 6 of those. And it's a probability, so we have a denominator, and what we're doing here is out of 45 numbers, we're choosing any 6. This is the probability that we want. And when I computed this one, I got 0.401. Problem 51 says that suppose that blinking causes a person's eyes to be closed 10% of the time. So the probability of eyes being closed, that's going to happen 10% of the time. And what we want is if a photographer takes a picture of 3 people, what is the probability that all 3 have their eyes open? What we want is this. What's the probability that all 3 have eyes open? Well, here's our 3 people, and we want this person to have eyes open, this person to have eyes open, this person to have eyes open. And we're told that the probability of having eyes closed is 0.10, so the probability of not closed, open, that must be 0.9. Let's get that to right, 0.9. Second person, same, open, 0.9, 0.9. So we're going to get 0.9 to the third. And when I computed that one, I got 0.729.